Hi, I'm David from TestQube, and in total I've written over 3,000 DSAT practice problems. Over the last 5 years, TestQube has helped over 500 students get a score of 750 or better on the reading and writing section. Today, I'm going to share with you what I believe to be the 2 most difficult questions to ever be released on an SAT reading and writing exam. These questions have been uploaded virally online and have been claimed to be from official test dates of the SAT. Without further ado, let's get into the first one. Alright, so let's get into this. So we can see that the question is asking which finding, if true, would most directly support the hypothesis presented in the text. And so, with support questions like this, we want to first underline the hypothesis. This will give us a good idea of the evidence we need to provide for the assertion. Okay, so the passage argues that this P antipodarum could serve as a valuable proxy for X laevis in nanoparticle bioaccumulation testing, eliminating or obviating the need for intrusive sampling of vertebrates. So what would most support the idea that this P antipodarum is a suitable stand-in for X larvis? Okay, so to be a valuable proxy, 2 things essentially matter according to the hypothesis. So 1, bioaccumulation to be comparable between P antipodarum and X laevis, so the data are meaningful. And then number 2, the testing process should be more efficient or less harmful when using P antipodarum. This number 2 is incredibly important in reassessing the answer choices. So, let's look at A first. So A says, compared with X laevis, P antipodarum can tolerate significantly higher CuONP concentrations without displaying any negative effects. Okay, so why would this be wrong? It suggests that P antipodarum reacts less sensitively, which might actually make it a worse proxy, not better. If they don't show effects when X laevis would, the data would be misleading. And then let's look at B. It is easier to detect low and harmless concentrations of CuONPs in P antipodarum than it is to detect high and harmful concentrations of CuONPs in X laevis. So this would be right. And why would it be right? Because it supports the idea that P antipodarum could be a more sensitive, efficient, and ethical testing tool, making it a better proxy overall. So this aligns directly with the motivation to replace costly and intrusive sampling of X laevis. Now let's look at C. Why would C be wrong? C says CuONP concentrations in P antipodarum tend to vary more from individual to individual than do CuON concentrations in X laevis when the species are exposed to similar levels of CuONPs. So this would be the opposite of what we're looking for, right? Because more variability would make P antipodarum less reliable as a proxy, not supportive. Finally, let's look at D. In comparable environments, P antipodarum and X laevis display comparable rates of CuONP uptake. So this is a very tempting choice, and a lot of students tend to pick it. It supports the idea that P antipodarum could be approximate what happens in X laevis. But while this supports the idea of bioaccumulation comparability, it doesn't support the idea of, in this case, P antipodarum being superior practically, right, which the passage emphasized. So it doesn't address that second part of the assertion that we're looking for. And so ultimately, what can we conclude? D supports the biological plausibility of the proxy, but B supports both the biological role and the practical advantage, making it a more direct and comprehensive support of the hypothesis. So to put it in easy words, B satisfies both parts of the hypothesis, whereas D only supports the one part. Okay, so now let's move on to the second question here. And so go ahead and pause real quick to read over text 1 and text 2. Okay, so now let's look at the question. So the question reads, based on the text, the author of text 1 and the author of text 2 would most likely give the same answer to which question? So of paired passage questions, this tends to be the most difficult kind of question because trying to find a difference is actually easier than trying to find a similarity between the passages. So let's look at what the actual texts are saying. So text 1 is basically saying, Meng and colleagues use barriers to exclude other pathways, including root to root. And this is praised. He and colleagues, however, didn't, which is basically a key flaw of their experimental design. And so text 1 supports Meng's method as superior and claims it excludes other nutrient pathways. And then what does text 2 say? So text 2 is basically saying that, yes, Meng tried to exclude root-to-root transfer, but even Meng's barriers might have let liquids through, and liquids can carry nutrients. So their setup can't definitively prove that CMN was the only pathway. Okay, so now that we have this information, let's go through the wrong answers first. So starting with choice B. Are the barriers used in Meng and colleagues' study sufficient to ensure that nutrient transfer could only occur via CMN? Seems promising, right? But here's the twist. Text 1 would say yes. they praised Meng's methods as excluding other pathways, but text 2, however, is a clear no. The barrier also allows liquids, meaning other transfer methods could have been in play. So they disagree. Let's eliminate B. Now looking at C. Is there an available barrier method that can block roots and liquids while allowing fungal strands through? So this one's essentially too speculative. But why? So text 2 hints that such a perfect barrier doesn't exist. That's the problem. But text 1 says nothing about liquid permeability or barrier materials, allowing us to conclude that only one author would address this, and we could cross off C. And then finally D. Do plants that transfer nutrients through a root-to-root pathway also transfer nutrients via CMN? Okay, now we're just making things up, right? So neither text talks about plants using both pathways at once. They're concerned about isolating pathways, not comparing usage between the two paths. And so there's no shared answer here, and so we can rule out D. And so now the unexpected winner, choice A. And so most students would never pick this answer. Why? Because the question is asking, did he and colleagues' study effectively exclude any nutrient pathway other than a CMN? So this might seem like it's only about text 1, which clearly says, he and colleagues did not take the crucial step to exclude other pathways. But here's the kicker. Even text 2, though it never mentions he, says even Meng didn't fully exclude other transfer methods. So if Meng's methods were incomplete, then we can conclude or imply that he's were definitely incomplete. And so both would say no if they were likely addressed with the same question. He's study did not effectively exclude other pathways. And just like that, the most overlooked specific question turns out to be the one both authors agree on. And so with that, we went over 2 of the hardest questions on the digital SAT reading and writing section. If you guys have any questions or want to learn more, subscribe and like TestQube's channel. Thank you.